Thank you for the invitation to be here. It's a pleasure to be here and to speak on this topic area to you. I've got this question a couple times. I don't speak to purely swine audiences very often. If this might be the first time, I've spoken to kind of multi-species audiences and a lot of dairy audiences, but never a full swine audience. When I received the invitation from Hyatt to present here today, I was a little confused at first as to why I was invited, and he explained kind of the objective of what he was hoping to have me do here this morning, and really give an overview of our experience, my experience in research, particularly in the dairy industry's experience related to application of precision feeding and how that might translate to you, at least in terms of some of the concepts and things. So I'm going to be speaking purely on dairy cattle this morning, and with the idea that some of the concepts that I'm going to bring to you will translate, or at least get you thinking about how you can then apply that within your own industry and some of the challenges and opportunities that we have when it comes to application of precision feeding. So one of the reasons that we're here and we're talking about this whole idea of precision and precision feeding is the fact that we have a lot of advancement in what we call precision livestock management, or the Europeans will call that precision livestock farming. And generally that comes under kind of a broad umbrella or broad description. And I have a kind of a definition here: automation using sensor-based management tools that define animal needs and robotic equipment that automatically delivers individual animal management applications. And so kind of a mouthful, but the whole idea is that we're using technology and robotics and automation to either automate management tasks or individual kind of management, animal management applications. And the dairy industry's been quite involved in this, or at least the uptake of that within the dairy industry has been quite large over the last number of years, particularly focused on the application of various precision technologies or automated technologies for the automation of various management tasks. And probably the biggest example of that, and I'll talk a little bit about that in just terms of some of the description here this morning, is related to automated milking, but we also have automation in feeding. That's what we're going to get into a little bit here this morning as well, talk about how we've applied automation to feeding and precision feeding in dairy cows. But then a lot of it has been also related to other things: reproductive management, health monitoring, barn cleaning, barn ventilation, bedding management. All these kind of things are currently being automated or have been automated in the dairy industry, and we continue to see growth in all of those areas. One of the first things I want to kind of lay the groundwork here this morning is to talk a little bit about why we're seeing this and why we're seeing this rapid adoption of technology within the dairy industry particularly. And I think we heard some of this yesterday, and probably not a big surprise is the challenges that we have with labor availability. And we know that they have been an issue, they continue to be an issue, and will continue to be an issue going forward in the future. And the whole issue with labor availability isn't necessarily restricted to our livestock industries. We know that that's happening in the world around us. And as a result of that, we're needing to find solutions to adapt to that, to work within some of those constraints. And technology does allow for some potential removal or minimization of labor within various industries. And so we're seeing the development of various technologies being adopted at fairly high rates to combat some of those labor challenges that we have. And again, we're seeing that in the dairy industry, we're seeing that in other livestock industries, and we're seeing that in the world around us in general. So the uptake of robotics in terms of manufacturing, in terms of supply chain management, distribution, has increased exponentially in the last couple of years, particularly even through the pandemic, in terms of trying to find ways of improving efficiency, minimizing human kind of labor requirements. Now, one of the interesting points coming back to the dairy industry when it comes to this whole idea of labor is that technology has not only been employed there to help reduce labor, but also has some potentially other benefits. And this is something that we've actually explored in some of our research. And one of the interesting things from the farmer's perspective that they have really cited and kind of held on to is the idea that technology can also have benefits for their quality of life. And it might sound kind of interesting, but we've actually looked at this from a research perspective and explored this a little bit more detail of why they're suggesting these kind of things. And this is a study we did of Canadian producers, dairy farmers who are using robotic milking technology. And if you're not aware of robotic milking technology in the dairy industry, we've seen an exponential growth in that. So about 10 years ago, about 2% of Canadian dairy farmers were using robotic milking units. Now we're looking at about 15% of Canadian producers using robotic milking units for their cows, potentially up to about 20% of the dairy cows in Canada currently being milked with robots. And the idea behind the milking robot is that the cow goes to that milking robot voluntarily. The milking robot basically does the whole process of milking that cow without any human intervention. It's not done at set times of the day, it's done throughout the day. And so the producer has less kind of labor requirements related to milking those cows at certain time periods of the day, particularly often at early morning and later times of the day. And so their time gets more flexible. The amount of time that they need to devote to that management task is not necessarily there, and they can devote that time to other things. So about 5 years ago, well, this paper was published about 5 years ago, but a couple years before that, we did a survey of about 1/3 of the Canadian producers who are currently at that time milking with robots. And we asked them questions about their transition to robotic milking and some of the benefits that they observed at that time. And this is just one result that came out of that study, where we asked on a scale of 1 to 5, basically 1 being disagree, 5 being strongly agree, how they perceive certain things as it related to adopting this technology. And so a couple of the results that came from that on a scale of 1 to 5, again, on average, though, mostly agreeing or even highly agreeing that robotic milking had improved their profitability, met their expectations. And probably the most interesting thing was that, and the most highly rated thing that they suggested, was that the adoption of that technology had improved the quality of their lives as well as the lives of their animals. And I think there's reasons for that we'll discuss in a couple of minutes. But we dove into that question of the quality of their life a little bit more, and we asked further, okay, what aspects of their quality of life had improved? And the things that they commonly cited in the study were increased flexibility with time, work being less physical on their bodies, easier employee management, improved herd health, and herd management. And so, again, benefits to their personal lives, but also they even cited benefits to their animals as being part of kind of the benefits to themselves. And the vast majority of those producers suggested that they would recommend transitioning to robotic milking to their fellow dairy farmers. Now, shortly after we did that study, I had a graduate student who was just finishing up. She was starting a postdoc with me, and she was interested in delving into this question a little bit deeper in terms of trying to find out what benefits this was actually having on the kind of personal lives of these dairy farmers. And so my former student, Dr. Megan King, did a study looking at the mental health of these producers and actually sent out a survey to a cohort of dairy producers in Ontario with a survey around mental health and stress in those producers. And what Megan found at the time, and this was published last year in the Animal Welfare Journal, what she found was that compared to results of a previous study that had been done by one of my colleagues at the University of Guelph surveying farmer mental health in general in Canada, she had found that those farmers who had adopted robotic technology had actually were slightly less stressed or had improved markers of mental health as compared to the general dairy farming population. And further to that, even within those producers who adopted technology, those producers who adopted even more technology, like automated feeding and other things, showed even more resilience and more ability to cope with stressors in their lives than kind of the general farming population. And so interesting how technology can basically allow us to not only reduce kind of management or labor-associated management tasks on farm, but at the same time have very positive impacts, or going with that, positive impacts on the mental health of these producers at the same time. When that study was published, one of my colleagues at the university sent me an email, like within a few days. This study had been picked up by various media outlets, newspapers, radio stations, etc. across Canada, and I received an email from one of my colleagues who works in a different department. He comes from a farming background, but does not work currently on a farm, but his brother has a dairy farm, and he sent me this email, and I had his permission to quote him on this, and he said, "I sent my brother, as a dairy farmer with robotic milkers, the article about quality of life for farmers and cows with technology. And although he feels there are significant benefits in terms of milk production, calmness of cows, and herd health, so all good things from the cow's perspective, he said the lifestyle value is huge." And he says, whenever someone asks me if robots pay, I tell them, who cares? Now, I think at the end of the day, he probably does care if his robots pay and they're economically viable for his farm. But just the kind of the strength of that statement suggests that there's more to even just the adoption of technology than kind of the bottom line, so to speak, on the farm. And in the case of this person here, they're valuing kind of some of the changes that technology was having in terms of their own farm management just as highly as maybe the economic benefits that they might result in as well. Now, some of the benefit there then comes back to beyond just kind of labor. What technology allows us to do is actually do things more accurately and precisely on farm. And that's where I kind of want to get into my presentation more here today, speaking specifically when it comes to feeding and precision feeding, is our ability to be more accurate and precise in those management tasks. And that's where we really see the benefits from the animal's perspective. And again, if we can be more accurate, we can be more precise, we can not only potentially improve production, we can improve health, and then also improve efficiency, minimize nutrient waste, and all those kind of things at the same time. And so those things at the end of the day then translate into benefits, both for the animals as well as the producers who care for them. And so for the next kind of part of my presentation, the rest of my presentation, I want to focus specifically on kind of the application of technology and precision in the feeding of dairy cows. And again, to get you to think about how some of these concepts and some of the challenges, some of the opportunities that we have on the dairy side may also then translate or cross over, so to speak, to the swine industry. Now, one of the biggest challenges actually that we have in the dairy industry is that 30 years ago, 40 years ago, we moved away from kind of individually feeding animals and even component feeding cows, different feed ingredients, to feeding what we call a total mixed ration, what you see here in this picture, which is a combined ration of all the different feed ingredients of the animals, so their forage components of the diets, as well as their energy and protein supplements, vitamins, minerals, all those kind of things mixed up into one diet that's balanced, it's homogeneous, and it's balanced to meet the needs of kind of the average cow in the group. And again, there's challenges with that because, again, we're typically feeding those cows in our larger farms in groups, and we're feeding that diet as one group to that whole group of cows. And again, while that on average can work, you can imagine that there can be inefficiencies there, as not every animal is going to have the same need, and depending on their individual level of production as well as their individual stage of lactation. As we get to bigger and bigger farms, we can produce more and more different diets, and we can actually try to be a little bit more accurate and precise in terms of delivery there, but we still are not necessarily meeting the needs of individual cows in all those circumstances. Now, we do have challenges, though, even within these kind of scenarios in terms of meeting the individual needs of those cows, the group needs, so to speak, of those cows, as well as the individual needs. And I'm going to first talk about some of the challenges that we actually have at a herd level in terms of being accurate and precise, and then speak about how we actually have those same challenges, and probably even more so as we move down to the individual animal level and try to feed those animals individually and be precise in that. And one of the challenges that I have even in talking on this subject area is I talk about precision. And when we talk about precision feeding, what we're actually talking about when we talk about precision feeding is actually being accurate and precise. Precision is actually basically how well we hit that target in the same spot. But before we can even talk about how precise we are in terms of hitting a target, we actually have to hit the target, so to speak. And that's being accurate, right? And so being accurate is actually matching, say, the diet that's going to that animal to the actual requirement of that animal. And then the precision is how closely we get to do that and how consistently we do that day in and out. And we have that as a huge issue even at a group level in dairy cows. And I just want to provide a few examples of that just to highlight that, and then some of the challenges or opportunities that we have associated with that. And so the question that we have in the dairy industry is, even at a herd level, do we have technology, or can we use technology to actually improve the accuracy and precision of the diets that we're feeding to our cows? And one of the real questions that we have in the dairy industry is, are we actually accurately delivering diets? So we've got diets that are on paper. We've got good nutritional models that say this is what we should be feeding our cows. We've got good information about the different feed ingredients that we have. But rather than providing, say, a complete feed to dairy cows, as I talked about before, the diets we put together are going to be a mixture of all different types of feed ingredients. There's going to be variability there in terms of dry matter content, and that varies from day to day, particularly with forages and silage forages, corn silage, haylage, all those kind of things that we feed to cows. Variability there in terms of moisture content, even nutrient content, and then other ingredients, you can have a little bit of variation there too. And then we have people who actually put those diets together and are operating machines to dump those ingredients together, put them together on a daily basis. And the question then becomes does what actually get put together for those animals match what actually gets delivered to the animals at the end of the day? And you can imagine that the answer to that is actually not, and we don't actually see diets being delivered very accurately. We did a study about 10 years ago on a cohort of dairy farms in Ontario, looking at how well the diet fed matched which was formulated on paper for those animals. And what we did is we took this cohort of farms and we sampled their feed for 7 consecutive days, both in the summer and winter time, analyzed those feed samples, went back to the formulated diets and compared those things. And this is just some of the results from that. So for those diets that were fed, they exceeded the formulation for a variety of different nutrients, and they underfed for other nutrients on average in that case. Now, overfeeding nutrients isn't necessarily a problem in terms of from a production standpoint. We tend to overformulate anyways in the dairy industry to make sure that we're kind of meeting the top end animals, especially if we're feeding animals at a group level. Underfeeding, obviously, if we're chronically doing that, we're potentially going to be restricting nutrients on animals and maybe not meeting our production targets. Now, one of the points that I wanted to make here is that these are just averages, and if you look at the actual paper, what we saw across different farms is huge variation from overfeeding to underfeeding on individual dietary ingredients. And again, with that comes inefficiency, comes waste at the same time. And there's obviously cost associated with that as well. We didn't look at that in this study. There's been some other work in the U.S. At a larger scale and larger farms looking at these similar types of things. This is some data that was published again about 6-7 years ago on deviations from a formulated target weight on ingredients loaded into a high group total mixed ration, that's the diet for the dairy cows, on 26 large California dairies that varied from over 1,000 to almost 7,000 cows per farm. And what they observed was that the deviation from target weight on those diets across those farms varied from only about a percentage up to some farms chronically kind of deviating at kind of the 5 to 6% on average range, sometimes ranging up to over 10% on a daily basis. And then when they looked at it from a cost perspective, and a deviation from their target cost. They saw, on average, they're always over-costing those diets, and again, lots of variation between farms and within farms, particularly with some farms, like in this case here, there's a little bit of an outlier here, but this farm going up to 10% deviation in cost on a daily basis from what their target formulation was. And again, the question then becomes, well, what is contributing to that variation? And again, one of our challenges in the dairy industry is we have a lot of variation in feed ingredients. And to be able to pick up on those on a day-to-day basis and be able to manage that becomes very difficult unless we employ technology that allows us to monitor and track those ingredients on a day-to-day basis, as well as those putting those diets together and the protocols that they have in place to do so. And so, again, we do have technologies available to us in the dairy industry. A lot of those, from a tracking perspective, are based on NIR technology that we're using in general in the feed industry. But again, mounting, say, NIR tractors, even onto loading buckets, onto silage cutters, those kind of things, tracking those things in the bunk, and then using proper software to actually track individual loads, ingredients, as well as protocols that are being followed on farm, are all things that can be done and are being done. And these types of technologies are available to producers. They are being adopted, and they're being used kind of at an increasing rate within our industry to try to minimize some of these variations from actually occurring. Now, one of the kind of more interesting pieces from some of this work and this whole concept is how precisely we actually get diets to cows as well. And I mentioned before, we can hit the target, but then the question is, do we hit that target day in, day out the same way? And again, this might be a little abstract from the swine industry because again, our ingredients can vary so much in that, and even the protocols from a feeding perspective can vary so much that we might not necessarily end up delivering the same diet that looks the same consistently day in, day out to these animals. And so, again, from that study I described before, when we sampled these farms for 7 consecutive days, we looked at the variability in nutrient content of those diets across those 7 days. So we calculated a coefficient of variation across the 7 days, both in summer and wintertime, and then correlated that back to various production parameters on those farms. And so this is just one example of that. This is the coefficient of variation in the net energy of lactation, so the net energy of the diet for lactation on these farms. And again, these aren't very high coefficient of variation. Typically, we get scared when we see CVs over 5%. These are all less than 2.5% on average. But even within that kind of small or low end and small range, we see a negative correlation here with the dry matter intake level of the cows. And obviously, dry matter intake is a big driver for milk production. And so you see this negative relationship here where every half-point increase in the CV was associated with less dry matter intake. And jumping to my next slide, same thing with less milk. So same data set, about 3.2 kilos less milk. Ignoring this outlier farm kind of here and here, even across this range, that's 1.5 points. That's about a 10 kilogram difference in milk production between kind of farms that are slightly more consistent versus those that are less consistent. That's probably on average, these farms are producing on average 30 to 40 kilograms of milk. That's like a 25 to 30% difference in milk production that we're just explaining based on day-to-day variation in terms of what those animals are receiving in their diet. So nothing to do with the diets themselves, nothing to do with the management on farm, just day-to-day variation. And so, again, a huge issue for the dairy industry in terms of trying to minimize some of that variation and think about what are some of the bottlenecks that are causing that variation. And for us in the dairy industry, a lot of it comes back to human variation because a lot of these things, when it comes to putting diets together, relate back to human variability associated with protocols and actual on-farm tasks that are done by humans. And so, again, we know that when it comes to dairy cows, consistency is kind of key. Again, I was tasked not to talk about the rumen today, but the rumen of the dairy cow is particularly thrives on consistency in feed that goes in, consistency in the bacteria that work within that rumen, and then other aspects of dairy management are the same. And the more consistent we can keep that, the better the outcomes that we're going to see. And so again, how do we combat that, or how is the industry combating that? And again, that's the application of technology. And so we have now various technologies, again, at a herd level to not only prepare diets, but even deliver diets to cows in farms. So a variety of technologies. Actually, here in Quebec, we see a couple companies that are leading the charge, so to speak, as well as other companies worldwide at the development of that type of technology to not only mix feed for cows, but actually deliver it all without basically any human kind of intervention. And that's being scaled up to larger and larger farms as we speak at this time. Now, that's kind of at a herd level, and I think that's a little bit more abstract from your perspective. But where it gets a little bit closer to home, so to speak, is when we start to think about how we then apply these concepts and think about precision at the individual animal level. And that's where I think we have a lot more opportunity within other industries like the swine industry as well. At the dairy industry, we've been wrestling with this for a number of years. If we think back, actually, in the dairy industry 40, 50 years ago, most of the cows were actually individually housed or tied, and we would actually feed those cows to their individual needs. Now, there still is a lot of that kind of housing going on, but even within that, we're not necessarily thinking in that manner. We used to have more opportunities on dairy farms years ago in terms of having individual supplementation. That went away, but we're starting to, again, think about that as we employ some technologies like robotic milking that actually allow us to feed those animals individually. And so it then starts to beg questions like I have here on the screen is, are we able to then accurately meet the needs of those animals? Can we target certain feeds or nutrients to those animals at certain time points when they're needed most? And then finally there, can we maintain precision in that as well and get that consistency that I talked about earlier as well? And so what I want to do is walk through some of these questions and some of the opportunities and challenges that we have on this front. Again, the reason that we have this opportunity currently in the dairy industry relates primarily, again, to this adoption of robotic milking technology. And as I mentioned before, the idea behind the robotic milking is that the cow enters voluntarily, she milks at her own time, and to do that, or to get her there, we use barn management and design, but we also use feed that we provide in those robotic milking units to attract them to that robot. And so the feed is there primarily to attract that cow to that robot, but at the same time, we can then vary the amount and even types of feed that we provide to those animals when they go to those robotic milking units, and do so based on the individual needs of that animal, based on their stage of lactation, their production level, growth, whatever it might be that we need to feed that animal for. We can start to think about managing the nutrition of that cow individually. Now, we can only do so, and again, this is a challenge for the dairy industry, actually provides more opportunity within other industries because, again, it's only a small proportion of the diet that they're actually getting there. And generally, we're only looking at about 10 to maybe 20, 25% of their total dry matter being able to be fed through that robotic unit, whereas the vast majority, 75, 80, up to 90% of their diet actually comes from the rest of the feed that those cows still consume in the feed bunk in common with the rest of their herd mates. And so again, our opportunity to precision feed those animals individually is limited to that only small proportion of their total diet. But even within that, we do have some opportunity there. And so that first question is, are we able to accurately meet the individual needs, or can we actually try to target at different stages of lactation different amounts of nutrient consumption in those animals? And again, without getting too deep into it, the short answer would be yes, we can do that, and we can vary the amount of feed that we provide to cows at different stages of lactation when they have different needs, so to speak, and we can do that on an individual cow basis. And this is just an example of some data that I pulled from our research farm, where each of these dots represents an individual cow across a standard lactation for a dairy cow, so about 300 days, give or take. And this is the amount of feed that is provided in the robot to those cows, so ranging from very little to up to 7 or 8 kilograms per day on a dry matter basis for those cows. And so what this shows is that we do have some opportunity to vary that. We know that cows' nutritional requirements vary across that stage of lactation. They're going to ramp up as she gets into kind of what we call her peak lactation, which occurs around 60 days in milk. And then as she goes down in production, we can then bring down the amount of feed that we provide to her, and we can match that. As long as, and again, this is a challenge in the dairy industry, but again, we have this to some degree figured out, as long as we can have good predictions of her total dry matter intake and her nutritional requirements, and that's where our nutritional models come into play. If we've got good models that we can use to predict her total dry matter intake, we can predict how much feed she's going to eat at the feed bunk, how much feed she'll eat at the robot, and then we can vary the amount of feed at the robot and the type of feed, the nutritional composition of that feed to meet the requirements of those animals at those times. Question then is, can we actually target certain feeds or nutrients when they're needed most? And I think that's an important question for us as we move forward, because there are definitely certain time periods of the production life of that animal, particularly the lactating animals, in terms of where they may need more nutrients than, say, other times. And one of those time periods is in early lactation. And again, as with most mammals, the cows will mobilize fat in the beginning of lactation to meet her energy requirements for production. And when that happens excessively, then we end up with a condition called ketosis, subclinical ketosis, very prevalent in the dairy industry. Incidence rate can be anywhere from 20 to 40% in dairy cows of subclinical ketosis in early lactation, in the first few weeks of lactation. One of the things that we noticed actually in research from a few years ago, and this is one of our studies, is that when we looked at robotic milking cows, which actually tend to have as high, if not a higher incidence of ketosis in early lactation, one of the things that we noticed is across the industry, and this is on a large sample of cows from a variety of different farms, is that those cows who got ketosis not only had a little bit higher production in the first week of lactation, which diminished, so they lost that kind of production advantage, but during that time period, they were actually producing more milk per kilogram of feed that we were individually feeding those cows in their robotic milking units, which again to some might look like efficiency, but in this case it's suggested to us that we weren't meeting the requirements of those animals at that time, and we weren't properly meeting their nutrient requirements during that early lactation period, and we could potentially do better. And so that's been a real focus of our research in the last few years, and trying to push the industry in terms of trying to find alternative ways, alternative feeds even, in terms of getting more energy into those animals in that early lactation period, while at the same time keeping those animals healthier. It'd be easier for me to say, let's push some more corn through that robot, right, and get some more energy into those cows. But the challenge with that, particularly for a dairy cow in early lactation, is that that's going to upset her rumen again and potentially cause something called acidosis, which again has negative consequences for that animal. And so we've been toying with and playing with trying to find alternative energy sources, sugar sources, other gluconeogenic precursors that we can feed to those cows in early lactation through those robots, individually supplementing to actually prevent some of these conditions like this from occurring. And this is just one example of that. Again, a study that was published a couple years ago from our group looking at the feeding of a molasses-based liquid feed supplement to those cows, about a 40% sugar product. And with the idea of supplementing the cow's feed that was already in the robot, their pellet that they were getting there, with this liquid feed source, and actually minimizing the risk of ketosis risk. Now, we did have some success there in terms of minimizing recurring cases. We didn't eliminate ketosis risk altogether, suggesting that we have some more work to do, and we're currently doing other projects in this area. But it does show that we do have some opportunity there, or at least gave us some hope in terms of that we do have some opportunity there to be a little bit more targeted for these cows in early lactation in order to meet their requirements a little bit better. Now, one of the biggest challenges that we actually have in all of this is maintaining kind of the precision in these approaches. And a lot of that comes back to the fact that the ability to feed these cows comes back to how often they're actually going to the robot and how much feed they're actually consuming in the robot at a given time period. And I bring up this graph again because I was a little bit devious when I showed you before. Well, we can vary, but the fact of the matter is we weren't trying to vary the cows in this situation. And in the case of this situation, the farm actually had a set feeding rate for those animals in early lactation up to 120 days of milk. They were supposed to receive 6 kilograms per day, and past 120 days in milk, they were actually supposed to receive 4 kilograms per day, every animal. And so what this graph tells us is that we're not meeting those targets, actually. And again, this isn't the right way, so if there's anybody who knows anything about robotic milking management and how we should be feeding cows with robots, this isn't the way we should be managing their feed. This is the way it was happening, and we're messing up very badly and resulting in huge variation between animals across days in terms of what individual cows were actually receiving. And so they're supposed to be getting 6 kilograms a day. Some are getting more, some are getting less, far less. And it comes back to what might be contributing, or what I want to talk through is what might actually be contributing to some of that variation. And so simple things like how often the cows milk per day can have an influence, because again, the amount they receive is going to be dictated by how often they milk on average. The machine, in the case of a robotic milking unit, will apportion the amount of feed per meal based on the average milking frequency of the cow. If the cow is very consistent and goes to that milking unit 3 times per day, every day, then it's going to split up that 6 kilograms, for example, into 3 2-kilogram meals. If she goes on average twice a day, it's going to do it in 2 3-kilogram meals. But the machine actually reprograms that every few days to figure out based on the average milking frequency of that cow. And as long as that cow is very consistent, that's fine. But if you start to see that cow suddenly become inconsistent in terms of her milking frequency, then those algorithms don't work necessarily as good as we want, because basically the behavior of the cow starts messing up with the math that the system uses to try apportion that feed to the cow. And as a result of that, we don't necessarily see then the average consumption level or feed provided to those cows met relative to what we expect. Other things can be important there as well, as including, say, how fast we're dispensing that feed to that animal and how much time that animal is actually spending in that milking unit. And this comes back to the behavior of the animals, including the eating rate of various feed types. And so it comes back to how fast those animals can eat that feed. Now, I have no idea how fast a pig eats concentrate, but I do know how fast a cow does. And that's going to vary with the type of feed. So if I have a pelleted feed, that cow can probably eat that feed at 300 to 400 grams per minute, some of the higher producing, higher intake cows. If I have a meal or a ground grain, they're only going to be able to eat that at, say, 100 to 200 grams per minute. And what we found looking across the literature and all the data that we have, the average dairy cow eats feed at about 250 grams per minute, grain, specifically. And that's going to then dictate how much feed we can actually realistically expect that animal to eat in an individual meal while she's in that robotic milking unit getting her individual feed supplement. And so when we look at what the average cow does, eating at about 250 grams per minute, the average milking of a cow in a robot, for example, takes about 7 minutes, then that's an average of about 1.8 kilograms. So the average animal can eat about 1.8 kilograms in a given meal, in a given milking in a robotic milking unit. If I multiply that by 3 milkings per day, which would be kind of a target that we would have in the dairy industry in a robot, that would be 5.4 kilograms per day of concentrate that we can reasonably expect the average cow to consume. Now, some higher producing ones, some bigger animals can eat a little bit more, and some others maybe less, but that's what we'd expect on average. What's interesting about that is, independent of this kind of line of thought, a number of years ago, some colleagues produced a paper where they suggested that as we get over about 6 kilograms per day of feed allowance for cows in a robotic milking unit, the amount of feed that starts getting refused by cows starts to increase exponentially. And again, at the time, they hadn't really thought necessarily of the behavior of the animals in terms of what they were doing from an eating perspective. But when we tie these things together, what we realize is that as we get above this kind of feeding level, the amount of feed that gets refused increases because the cows just aren't physically able to eat that amount of feed in that amount of time. And so we need to think about what the animal is biologically capable of from a behavioral standpoint to explain kind of what might be going on here. And then what we see in the dairy industry in these robotic milking units is as we then increase these animals, or we try to push, say, too much grain into some animals that can't handle that, they start to refuse that, and we end up with variable outcomes and variable results as a result of that, as those animals might not be eating as much as we'd expect them to eat, and then at the same time, because of the way the system works, that feed sits in the unit, and then the next cow that comes in eats what's left over, and so that animal might end up eating more than what we predict, and so this whole idea of precision and accuracy kind of all gets thrown out the window. And so we need to make sure that we're matching kind of what's biologically capable of that animal to what we expect that animal actually to do. And so the question is, do the cows actually receive the amount consistently? And the reality is they don't in all circumstances. And as we try to actually push more feed into those animals, what we see is that consistency actually goes down. And that's where we have some challenge there. And again, this is just an example of that from a study we did looking at 2 levels of feeding basically cows in the robot, a high and a low level of feed in the robot versus the feed that they're getting from the rest of their ration, what we call their PMR, the partial mixed ration. And what I just want you to key in on is as the blue is basically our high level of feeding in the robot, and this is a standard deviation in intake. So this is basically like that coefficient of variation I was talking about earlier. This is just representing across days how much variability we're seeing in intake in those animals. So of their feed in the feed bunk, the PMR that they're eating, they're actually similar. Their total dry matter intake similar, but we actually see a lot more day-to-day variation in that concentrate. And again, if we're trying to promote precision, this isn't very precise. If when we try to actually feed those cows a certain amount and it just creates more variation. And so that's one of our challenges, is to try figure that out, because at the end of the day, they're quite consistent in terms of total dry matter intake, but you can imagine because of the different ingredients going in there, the composition of that dry matter intake is varying. And so we're not necessarily being accurate nor precise in those circumstances. One other thing that I wanted to mention, and I think it's kind of interesting because it's a new line of research that we're going down in here, is what else might be contributing to that variability. And again, I talked about the cow's behavior from an eating perspective. We know that beyond just the eating behavior of the cows, there's also a lot of other behavioral variability between cows. And for better or worse, what that's been described as in the scientific literature is the personality of cows. We know that you and I have different personalities. We all do different things the way we like. And animals are no different. Cows are no different, that they have their own sort of set kind of behavioral characteristics. And we've been looking at that relationship to how cows actually use technology, including robotic milkers, and feeding within those systems to try to explain some of that variation that we're seeing. And the way we do this is actually we subject cows to a novelty test. We subject them to a novel arena, a place they've never been into. And so we let the cow stand in a novel arena, basically see what she does with her time. Then we subject her to a novel object. So we give her, in this case, a bucket that she's never seen before. Look at how she interacts with it. Does she interact with it? Does she play with it? Does she walk away from it? Is she scared of it? And then we put a novel person in, so someone they've never seen before. We put them in a novel coveralls that they've never seen before and see how that cow reacts. Are they aggressive with that person, as you see this cow being, or are they shy and they stay away from that? We combine all the behaviors that we get from these experiments, and we basically classify then the cows as being things like more active, social, alert, or are they more vocal, fearful, or are they more bold or shy, more explorative, and then use that to explain some of the variation that we see in terms of the actual behavioral patterns of those cows when we put them in real life situations, so to speak. And so out of this project, we actually fed cows 2 levels of feed in the robot and then correlated that back to how they performed in the robot to their behavioral profile. And what we found, very interestingly, that at a low level of feed allowance in the robot, and we classified that low level of feed allowance as 3 kilograms per day, there was no real association of the behavioral profile, the personality profile of those cows with how much feed they would consume in the robot. And that's this line here. So this is their fear of a novel human. So this is kind of one scale that we looked at. So their fearfulness. And what we found is that those cows, regardless if they're fearful or not, basically they ate the exact amount that we allocated to them. However, when we tried to target a higher level of feed in the robot, we found that those cows who were less fearful ate that amount as predicted, but those cows that were more fearful of that novel human, also then that behavior translated in them not achieving the level of consumption that we wanted them to consume in the robot. And so, again, we've got individual variability in animals actually affecting their behavioral variability, actually affecting what we're trying to achieve from an intake standpoint in these animals. And so these are things that we're continuing to look at and trying to overcome. Some of our goals here is to look at the heritability of some of these behavioral traits so that we can actually use these things from a selection standpoint and actually look for animals that may perform better under these situations of technology adaptation or adoption, and use that information for kind of the betterment of the genetic selection process of those animals as well. Besides milking robots, and I threw this in, that's probably the milking robots primarily where we see technology adaptation when it comes to precision feeding. There are some other precision feeding scenarios that are available or starting to be developed, at least in the dairy industry. This is an example from Spain from a colleague that I work with quite a bit, Dr. Alex Back, who developed a system whereby in real time he can basically have cows come onto a rotary milking parlor like this. Cow comes in, she gets weighed. The minute she gets weighed, information related to her body weight gets sent to a computer where it combines that with her production targets, gets combined with her stage of lactation, her age, her growth requirements, all those kind of things, and she steps onto that that rotary parlor, and she's got a feed bin in front of her and a feed drop line that basically gets a feed delivered within 16 seconds of her getting on that unit, and that feed is blended to her individual need in a span of 16 seconds coming from a shed that's I'd say about 50 meters away. And in this situation here, I think he's got 4 or 5 feed hoppers that he can blend from different ingredients and put together an individualized feed for that individual animal. And I think this is kind of the future. In the milking robots, we're limited to like 2 feed types at this time period. And this is where the dairy industry is trying to go with this, is trying to incorporate more or multiple type feed types that we can blend in real time and actually have delivered to those animals to be able to, say, meet their individual needs. We also have other technologies, and I threw this in just kind of out of interest, but the fact is that we're trying to incorporate other technologies into these precision feeding strategies as well. Things like real-time information about body weight, body condition, even the other behavioral patterns of those animals we're trying to use and use the sensors that we have available to us. The dairy industry is being very progressive over the years in terms of development of behavioral sensors, things that tell us whether or not the cow's eating or ruminating, standing or lying or walking. A lot of wearable technology that's being incorporated for that. A lot of use of computer vision type technology as well now in terms of, again, identifying behaviors of cows if they're eating, lying, drinking. Also body condition scoring and lameness scoring of cows using computer vision type approaches. So again, using camera-based systems with advanced modeling techniques to basically program or understand whether or not, say, a cow is walking properly, or detecting small changes in body condition, and using that information then to support and enhance our nutritional management strategies on farm as well. And I just threw an example of this. If you've never seen this kind of thing, probably people have seen this, but this is just an example of, say, a behavioral recognition system. So not only recognizing individual cows, but also what those individual cows might be doing in an individual day. And so for every kind of second of the day, we can track if those cows are lying down, they're eating, they're drinking, standing, lying in a bed. We can even track feed allowance and disappearance, and so some of this technology is even tracking how much feed is there, the distribution of that feed, and trying to even correlate that to actual feed consumption levels in individual cows in a group environment at the same time. And so this is just an example just to get you thinking too of some of the opportunities that we have from a technology standpoint moving forward here in the industry as well. So with that, gets me to my take-home messages. Very simple. Technology is allowing for a lot of opportunities in the dairy industry, particularly or including in feeding and precision of feeding. A lot of that's being done to help reduce labor, minimize human variation, and I think that's part of our problem in a lot of management application. But, and I think most important from a nutrition standpoint, is really allowing for more targeted nutrient intake. So allowing to meet the needs of those individual animals, improve the health, production of those animals, even meet the behavioral needs of those animals, and then at the same time minimizing kind of waste that we are much needingly to do within the industry as well. So with that, I'd like to thank various funders for a lot of the work that I've described here today. Thank you for your attention, and hope we can answer a few questions if there's time.